All right, guys, today we're going to be talking about 2.8, which is two variable inequalities, and this is the last section in this particular chapter. So I know that makes you sad because you know that a review and a test is coming. But this section should be pretty much review for us, but I don't want to take anything for granted, so I want to go through a couple of examples and then kind of show you what you're going to see on your practice today. So first, we're going to look at this first one that I have written here. Y is greater than or equal to 3x minus 4. So again, you graph this just like you do a regular equation. We'll worry about this inequality symbol here in just a second. But you can kind of look at this, I guess, initially as y equals 3x minus 4. Just think about, well, how would I graph that? Well, as usual, when you're graphing a linear equation, you want to look at this y-intercept first, which is negative 4. So I would go down to negative 4 right here, and I would go ahead and put me a point right there. Okay? So go ahead and put a point at negative 4 as my y-intercept. And then I notice right here that my slope is a positive 3. And so I know that I need to go up 3 and over 1. Again, we can think about that as a fraction. So up 3 over 1, rise over run. I want to go up 1, 2, 3 over 1. And here's my other point. Now, at this point, this is when we've got to think about the fact that I'm dealing with an inequality, and I'm not dealing with just a plain old equation. So what I want you to remember here is you see this is greater than or equal to. Again, when I see this line underneath here, this is probably the best way to remember it. When I see this line underneath here, like either greater than or equal to, or even less than or equal to, like that, anytime I see that equal sign line underneath there, then I've got to think in my mind, then my graph should have a solid line, okay? So I'm just going to throw a protractor up here real quick, and I know that should be a solid line. This is going to be kind of rough, but it'll still get the point across. So there is the graph of my line. But again, I'm talking about not just one point along those lines, but I'm saying anything that's y is greater than or equal to 3x minus 4. Now, I know you've had Miss Nolan before, and she's taught you that when you see that greater than or equal to, then you know that's above the line, and that is absolutely true. And that's the direction that this would need to be shaded. My issue kinda is that sometimes when they're almost straight up and down like this, it's difficult to say, is this above the line? Is that below the line? Especially when it gets more straight up and down. And so another way that you can do this that I'm going to show you is that you can use a test point. And one of the best test points is actually 0, 0. It's the origin. And the reason that is such a good test point, especially if it's not on the line, and that's the only caveat to this, is it can't be on the line that you're actually graphing. But the reason that this is such a good test point is because that it cancels things out, okay? So I'm going to use this right here as my test point, 0, 0. And what I mean by that is this is my x coordinate and this is my y coordinate, right? 0, 0. So I can literally put this into my inequality that I'm dealing with. So I can put 0 in for y, greater than or equal to 3 times 0 minus 4. Now you notice what happens when you do that. Again, things begin to cancel out. So what you have on the left side, and I'm going to write it right over here, you still have 0 is greater than or equal to. The 3 times 0 goes away. So that cancels out basically, and all you're left with is negative 4. So the question becomes, is 0 greater than or equal to negative 4? Is that a true statement? Well, that may be a little bit counterintuitive to think about, but 0 is greater than or equal to negative 4. It is greater than negative 4 on the number line. And as a matter of fact, we can look right here. Here's negative 4, there's 0. These numbers going this way are greater, so we know that that is a true statement. Because that's a true statement, I'm going to shade toward 0, 0. So again, it still does the same exact thing, but this would be my shading right here. So any point over in this area should make this statement true. For example, if I were to choose negative 2, positive 2, I could put that in for my x and y, and it should come up as a true point. So any point in this particular area over in here would be true. So this would be the graph of my equation. Now let's use that same principle and thought process to talk about absolute value equations. Okay, so again, I'm going to look at this just like it's an equation and think about it like it's an equation, but I'm going to have this that I'm going to deal with here in just a minute. So let's just look at this real quick, and this should really be familiar because think about the parent graph of this. The parent graph of this would be y equals absolute value of x. Well, I have that, sort of, except that I also have a -2 in here. Well, the normal graph, y equals absolute value of x, we know looks like a V, and it would go from the origin and go up like that in that direction. I don't want to draw on a paper, so I'm not going to do that for you. But what would happen here? What kind of transformation is this actually? Well, we know that it's because it's inside the absolute value bars that it's a horizontal translation. And we also know that horizontal translations, or we should know by now, that horizontal translations are opposite of the way you think. So the fact that it has a -2 actually means that this would have been moved to the right 2 units. Okay? So I'm going to start at my origin, and I'm going to go over 2 units, and right here is the vertex of my absolute value graph. Now remember, from the things we've done over the last couple of days, we also have to look right here to see whether there's a stretch or compress, to see whether my graph is actually pointing upward or downward. Well, you notice there's nothing here, so we assume there's a positive, which means we know this graph is going to go up. We also see that there's nothing here as far as a number, like a stretch or compress, so we have to assume that there's a 1 right there, which means that our slope, and we think about this in terms of slope, is up 1 over 1, and up 1 over 1 again. And then again, this does the same thing in the opposite direction. Remember, it's symmetrical. So you're going to go up 1 over 1 this way and up 1 over 1 this way. So our graph has this resemblance. Now, here's the thing. Notice right here, I do not have a line underneath this. This is just less than. So when we have this situation with less than or even greater than, with no line underneath it, then we have to remember that this has to be a dashed line. It's not a solid line. So again, I'm going to use a protractor, and I'm just going to come in and make some dashed lines. And there we have it. There's our graph of our absolute value function. The only thing left to do now is to shade this graph. Now again, I'm looking at this, and it says y is less than. So would less than be below the line or above the line? Well, less than should indicate below the line. But again, I'm going to use a test point just to be sure, because you notice that 0, 0 is not included on my line, so I could use that as a test point. So I'm going to go ahead and put 0 in here for y, less than the absolute value of 0 minus 2. And of course, the absolute value of 0 minus 2 is -2, but the absolute value of -2 is actually 2. So what I'm left with, I'm going to move my work right over here, is I'm actually left with 0 is less than 2. Well, is that a true statement? Well, of course it is. 0 is less than 2. If I have no money and somebody else has $2, they are a lot better off than me. So that means that this point is included and needs to be shaded. So I would shade everything that is below my absolute value graph. Now here's the point that I want to get across to you. I know that you could graph these. As a matter of fact, you could pull up Desmos and you could graph these really, really quickly, a lot more quickly than I did here. So your assignment is not really going to be to graph, because it's going to be hard for you to graph anyway if you try to do this virtually. But your assignment is actually going to be to take a graph like this and try to figure out what the original equation was. So I'm going to work through a couple examples of that, and that may be a little bit counterintuitive, but it really is, it determines whether you really know what you're talking about or not. So let's look at a couple examples. Zoom this in. Hopefully you can see this. Let me zoom it back out just a little bit. All right, so again, we're to write an inequality for each of these graphs. So here's number 21. Now, first of all, just by looking at this, we can decide a couple of different things. One, this is a linear graph. So any linear graph, we know that it's going to have the format of y equals mx plus b. Now, because this is shaded in these directions like this, we know that this is actually an inequality. But again, we're going to think about it at least initially as just a plain old equation, okay? Another thing we can decide right off the bat is look at this solid line. So we know that because of the solid line, it either has to be greater than or equal to or less than or equal to. It has to be, just because it's got the solid line, all right? Now let's just think about how we would go about figuring out what this equation would be. Well, the first and probably easiest thing to do is look for this y-intercept. Look for this b. Well, if you notice right here, there's a -4, so that means these are going down by -1s. So you got to be really careful with that because sometimes they will throw in some different scales on you. So if we look at this, we start here at the origin, we go -1, -2. So I know that my y-intercept is -2. Guess what? I'm going to go ahead and fill that in. And we know there's going to be an x right there. That's just standard in our slope-intercept form. So now the only thing we really have to figure out is we have to figure out what our slope is. So we have to find 2 points that really show us what that might be. So I'm going to go ahead and choose this point right here, y-intercept that we figured out. And I'm going to go ahead and use this other point right here because it looks like it does cross right at those crosshairs. So again, if we're talking about slope, we're talking about rise over run. So let's figure out how far we go down. We actually go down 2. So down 2 would be -2. And then we go to the right, 1, 2, 3. So we go to the right, 3. And this makes sense because this graph is from left to right is going downhill. So it's a negative slope. So -2/3 x minus 2. We know that the y is going to be here as well. And we know it is going to be one of these two symbols. Again, how do we figure out what that is? Well, if you notice, I'm shaded above the line, okay? And so that would indicate to me above the line would be greater than or equal to. And again, you could take a test point. You could use 0, 0 because it would be right here. And you could put that in. So let's do that just real quick. 0 greater than or equal to 0 times x is just going to be 0. So we know that's going to go away. So literally all I have left is 0 is greater than or equal to -2. And that in fact is a true statement. So I am shaded the correct way. So this would be my answer. Now on your work that you're going to have, you just have to choose the correct one. I didn't want you to have to try to type in all this stuff into Google Forms because it is very, very difficult to do that. So all you have to do is choose the right equation. So as long as you kind of know what you're doing, you're going to be fine. So let's look at number 23. And this is an absolute value graph. Okay. So we know that just by looking at it. It's got that V shape that we look for. Okay. You'll also notice that there's dotted lines here. So we know that we're either going to be dealing with the greater than or the less than symbol. Okay. This is pointed upward. So we know it's going to be positive. So let's just think about this for just a second. We've got y equals absolute value of x. We know this is going to be positive. Do we have a stretch or a compression? Let's just think about where a vertex is. A vertex is right there. Okay? And you notice if I'm just looking at this right-hand side, if I go up 1 and over 1, I hit another point. If I go up 1 over 1, I hit another point. So we know that this is going to have a slope of 1. 1 divided by 1 is 1. So I really don't have a stretch or compress here. I don't have to worry about that at all, okay? The other thing we got to think about is, do I have a vertical change or a vertical transformation? Well, if you look at this, the vertex is lying on the x-axis, so there's no vertical change as well. But the one question we really have to ask is there a horizontal change? Well, if you notice, I am not on 0, 0. So that means there had to have been a shift of some sorts. Well, if you notice, I went to the right 1 unit. Okay, now remember, horizontal shifts are the opposite of what you think. So even though it went to the right 1 unit, which would usually be +1, when I write my equation, it actually needs to be a -1. So when I write this, I'm going to have y, and I'm going to have the absolute value of x -1 instead of +1. Now the only thing I have left to do at this point is to think about, okay, which one of these two symbols am I going to use? Am I going to use the greater than or the less than? Well, if you notice again, it is above the line. So our initial intuition, at least, is that this should be shaded above the line, which would be greater than. Okay. And again, what have we said that we can do to make sure? We can always use this test point right here of 0, 0. So if I put in 0 and 0, I'm going to get 0 is greater than the absolute value of 0 -1. And if you notice, I've got a statement here that ends up being 0 is greater than 0 -1 would be -1. The absolute value of -1 would be 1. Wait a minute. This does not make sense. 0 is not greater than 1. That is not true. Well, if you notice, this is shaded away from that point. So it again confirms to me that that is not a point that needed to be shaded. It actually needed to be shaded away from it. So that would be the correct answer. So my correct answer is right here. Y is greater than the absolute value of x -1. The other thing that I want to make sure that you're aware of, because you are going to have some word problems, is I want you to think about two words for me, okay? I want you to think about two words, and we've covered this once before, but I want to look at it again. And it's two sets of words, actually: at least and at most. So what I want you to think about is this. If your parent says, your cousin has a birthday next week, and I want you to spend at least $20 on a present. Well, is your parent telling you to spend less than $20, or are they saying, hey, get something nice, get something that's at least $20? So I want you to understand, when you see the word at least, that and it would be okay if you got exactly a $20 gift, right? But it needs to be at least 20. In other words, it could be 20, 21, 22, but not 19. Okay? So what they're really saying is, in this example, is at least would be greater than or equal to $20. Okay? Now let's do another scenario. So your parent again tells you, you say, well, I'm going to go to the movies with my buddies, and your parent says, well, at most I want you to spend $30. What they're really saying is, don't spend a dime over $30. Now, you could spend up to $30, but don't you dare spend $31. Well, what they're really saying when they say at most is they're saying less than or equal to $30. Now, again, that seems a little bit counterintuitive, because when you say at least, anybody would think less than, but it's actually greater than, okay? And given those examples that we looked at. And at most, again, you would almost think greater than, but it's actually less than. So hopefully that has been helpful. That will be very useful on one of the questions that you have, actually a couple of questions that you have. And so make sure that you take note of that as well. Hopefully this has been helpful today. And if you have any questions or concerns, obviously you can reach out to us and we can get in touch with you.